Hi grade 11s, welcome to Learn Extra. My name is Hayley and I'm here today to help you with some ratio, proportion and rate. Let's first see what we're going to be going through. So, I said we're going to be dealing with ratio, proportion and rate, and we're going to look at the definition of a ratio, the definition of proportion, and then we're going to look at some examples and definition of rate. So let's start off with our ratio. So what is a ratio and why is it important to us? A ratio is a comparison of two numbers. When you've got two numbers that we need to compare, we can deal with this in the form of a ratio. We call these numbers terms of the ratio. The nice thing about a ratio is it has no units. The quantities being compared are usually of the same kind or type. So when dealing with the ratio, we can write it in a few different ways. We can write it in words. Let's look at a ratio of the letter A to the letter B. So we can say in words, we can say A to B. We can also write it with a colon as A colon B, and as a fraction, A over B. Once we have it as a fraction, the nice thing about it is we can deal with it as if it was just a normal fraction. And because there are no units there to confuse us, it makes it easier. Let's look at a quick example. Suppose that we've got 12 boys in a class and 9 girls. So the ratio of boys to girls can be written in 3 different ways. Now what's very important about the ratio is to keep your terms constant. So we're looking for the ratio of boys to girls. So boys needs to be my first part of my ratio. So let's write it in words. I've got 12 boys to 9 girls. Now I don't have to write in the word boys and girls. I can actually say that is 12 to 9. That is the same thing. I can also write it with a colon. So I can say 12 boys to 9 girls. And lastly, the most important is I can say 12 boys to 9 girls. I can write it as a fraction. And what's so wonderful about this fraction is I can now deal with this fraction as normal, and I can simplify this. So how would I simplify? Let's divide both sides by. So 12 divided by 3, and we end up with 4, and 9 divided by 3 is 3. And that is our simplified form of the ratio. So in the class, we actually have 4 boys to every 3 girls. Let's move on now to a proportion. Proportion is just when we're looking with 2 ratios that are equal to each other. So for example, A to B is equal to C to D. Now if we go back one step to my ratio, what I ended up with here with my boys to girls when I simplified, that was a proportion. My 12 to 9 is equal to 4 to 3. So let's go back to the definition. The 4 quantities are said to form a proportion. In other words, proportions are no more than a comparison of ratios. When the ratios are equal, we say they're in proportion to each other. So let's look at an example, and then I want to take you through a few other examples to help solidify these concepts. So if we're looking to mix cement to patch up a crack in the wall, and if you've noticed that the builder, if you sit and you watch builders regularly, mix 6 pockets of cement to 18 pockets of sand. Now you want to mix cement to fill the crack. But if we had to take, let's get a little bit more space here, 6 pockets of cement and 18 pockets of sand, we've got way too much cement to fix this tiny little crack. So we need to mix the cement, but we want to mix it in the same proportion as 6 to 18. So if let's look at this as a fraction, 6 over 18, and I want to mix 2 cups of cement. So if I'm going to say, if I'm going to use 2 cups of cement, how many cups of sand do I need? And what I'm going to do here is I'm going to show you a different way of calculating this. Now, first let's take you through the steps you probably know. We look at 6. What do we do to 6 to create a 2? We're basically dividing it by 3. So what we do this side is we do the same thing. We divide by 3, and 18 divided by 3 gives me 6. So I need to mix the sand to cement in the ratio of 2 to 6. So let's go back up to the example, and you'll see we had 2 cups of cement and 6 cups of sand. Now we can see that that is the same proportion. I want to show you a different way of actually calculating this. I'm going to use blocks, and I hope I don't confuse you, and I hope this helps, but if you can get this concept, it actually makes ratios all that more easier to deal with. And I'll do another example to help you. In my blocks, what I'm going to do is I'm going to put my given values at the bottom. Everything that has been given to me. So what was given in this question was 6 pockets of cement and 18 pockets of sand. 6 pockets and 18 pockets of sand. Now I'm going to keep my unknowns going to be on top, or what I've been asked, my question. And I'm going to keep the blocks very set in that I'm going to have my cement on the left and my sand on the right. So how much cement did I want? I wanted 2 cups. And then I'm going to use that as a question mark. How many cups of sand do I need? Once we've set up the system, it actually is going to make it a whole lot easier for you to work with ratios. So how do I actually solve this? Whatever is below my question mark, I cross out and I multiply on the other side. So I'm crossing out what's below my question mark, multiplying on the other side. My line in the middle here means divide. So what I'm left with here is, let's just move that up a little bit. What I'm left with here is 18 times by 2 over 6. Now let's do that on our calculator because it will be easier. So I've got 18 times by, and I can use a fraction, 2, that's not a 2, 2 over 6, and I get my answer of 6. Oops. 6 cups. Now if we look back, that's what our solution we got above. So it's just a different way of calculating, and I'm going to try and use this the whole lesson and hopefully solidify these concepts for you. Let's do another example of dealing with ratio. Right, let's look at another example. If we want to make juice and we've got the ratio of 1 to 3, those are instructions on the bottle. What does those instructions mean? It means 1 part of the juice to 3 parts water. So I'm going to just write that. That's a J for the juice, and my 3 is a water. So for every 1 part of the juice, I need 3 parts of water. But it doesn't matter what that part is. It can be 1 cup of juice to 3 cups of water. It can be 1 liter of juice to 3 liters of water. That's what is so wonderful about ratios, is we're not dealing with a specific unit. So let's look at an example now. If I had 100 mils of juice, how much water do I need? So let's make it as water, and that's my question mark. What I want you to do when dealing with ratios is I want you to look for, there should be 3 values that are given to you and 1 that you're being asked. So what are our values that we've been given? We've been given the 1 we've been given a 3, and we've been given 100 moles. Now let's try my blocks. So, in my blocks, I'm going to set the question up, and thereafter it makes it easy for me to calculate. My given is at the bottom. Remember, we've got given at the bottom. So what have I been given? I've been given the ratio of 1 to 3. Then, specifically, keep it in the columns. My first column is my juice, and the second column is my water. What is the other value that I've been given? I've got 100 moles of juice. I can put in my moles, but I don't need to, as long as we remember to put our unit into our answer. Remember, we always have a reference. And the question is, how much water do we need? What's the steps that we need? Whatever is below my question mark, I cross out and I multiply on the other side. So what have I actually got here? I've got 3 times 100 over 1. So what is the solution to that? I don't think I need a calculator. I need 300 moles. Now you might have said to yourself, well, that was a very easy example and we knew we needed 300 moles to start. I just want you to get used to the way I deal with this. Let's do the same example with our ratio of 1 to 3. Let's now say, well, okay, if I've got 450 moles of water, how much juice do I actually need to add to get the right consistency? So my question mark is my juice. Again, I'm going to use my blocks. I can draw these blocks in. Right, my given, 1 to 3. Hasn't changed. This is my juice and that is my water. But what have I been given now? I've been given my water, 450 moles. And how much juice do I need? Whatever's below my question mark, I cross out and multiply on the other side. I'm multiplying by 1 doesn't really change anything. So what I actually have is 450 moles divided by 3. Do we need the calculator? Well, just in case, let's use the calculator. 450 divided by 3, and we see that we need 150 moles of juice. What's really nice about ratios as well is that you can actually use them to double check, are you correct? So what did we end up with as an answer here? We needed 150 moles of juice to 450 moles of water. Now if I take my calculator and I plug that into my calculator, 150 moles, and remember I said to you, ratios can be written as a fraction, so I'm going to divide by 450 and I'm going to press equals, and what do I actually see there? I see that my answer is 1 over 3. So our calculator told us that the answer was 1 over 3. And remember, we're dealing with ratio, so we can now write this as a colon, so that's 1 to 3. And you can see now that the answer that you got was 100% correct because our ratio hasn't changed. It is still 1 to 3. And that's a nice way to double check your solutions. So the last thing that we can actually do with ratios, and I'm going to show this to you now while we're dealing with the juice so that we are we've covered everything with ratios and we can do all the examples. So the last kind of question that they can ask you with ratios is a little bit of a tricky one where they don't give you the 3 values. So, but you need to be aware that it is still a ratio. So they will give you that the ratio is still 1 to 3 of making this juice. And now they'll say, well, okay, how many moles of juice and water do we need if we want to make, say, 2 liters of juice? That's 2 liters of already concentrated made juice. So what do we do in this case? Well, I just want to show you a picture of what would this look like if we had a cup of juice. Let's try to draw that cup again. Right, if we had a cup of juice, what would this actually look like? We would have one part here of the concentrate of the juice, and for every 1 part of juice, we would have 3 parts of water. So that is my ratio of 1 to 3. But what do I see when I look at it mixed in a cup like this? I see that I've actually got 1, 2, 3, 4 parts of liquid. I've got 4 different parts. 1 part was concentrate and 3 parts were the water. So I'm going to use that fact now to work out how much of each I need. So first of all, I've got 2 liters. So I'm going to convert that into milliliters because they want the answers in milliliters. So 2 liters, to get to milliliters, what do? We multiply by 1,000. And we end up with 2,000 milliliters of juice. Now I needed 4 parts. So I'm going to divide by 4, which basically gives me, let's see, I don't think we need a calculator, but let's do it on the calculator anyway. 2,000 divided by 4, we end up with 500 per part. So we actually have 500 moles per part. Has that answered my question? It hasn't. It's just given me how many moles are per part. And now we needed 1 part. So what we're going to do is we're going to take out how many moles per part and times it by 1 because I needed 1 part of concentrate. So that gives me 500 moles of concentrate, and I'm taking my per part, how many parts of water did we need? We needed 3 parts of water, and that's 1,500 moles of water. And now I've answered the question. I've told you that you need how much concentrate and how many moles of water. Can I check this again? Let's go back to how did I check it before? I checked it on my calculator. I said, well, okay, 500 divided by 1,500, and I get this 1 to 3. So, which means that my answer is correct. That's the nice thing about some of these questions where you can actually check your answer, then you actually know that you're doing the right thing. Don't forget your units. We have to deal with units, and so show your units. And I also want you to show all your working out so that your teacher or examiner knows exactly what you were kind of thinking. Right, let's move on to rate. What is a rate? A rate is a special kind of ratio. But in this case, we're dealing with 2 or possibly more quantities being compared. They've got different units. So an example of rate could be comparing the distance traveled by a car and the time it takes to travel. So the speed of the car, and that will basically gives you the speed of the car in kilometers per hour. What's nice about, what happened to my color? What's nice about that part of the rate is it actually tells you exactly what we're dealing with, because that's almost like my ratio. So kilometers per hour means kilometers divided by hour, and it helps you when you get to an example, which you'll see when we do examples later, of dealing what do we need to divide by what. We can also compare the time spent on a telephone, which I'm sure that you all do with your cell phones, and the cost of that call. So maybe we would deal with it in rands per minute or rands per second. So that kind of comparison where you've got 2 different quantities is called a rate. One of the important rates that you'll see, and you probably won't even realize that you're dealing with rate, is when you compare the value of the rand currency to, say, the US currency. You want to go overseas, when you want to buy something from America and you get a price in dollars. How do we compare that? So we will deal with an exchange rate, and you're going to get a rand to dollar in the form of how many rands per how many dollars. When you're working with rates, there's 2 important concepts to remember. You get a constant rate. A constant rate is when the quantities being compared are in direct proportion to each other. So let's think about your cost per, let's write this in, your rands per minute of speaking on the phone. The longer you speak, the more money you're going to spend. The less money you spend, the shorter time you've spent on the phone. But it is a constant rate. It doesn't change. And we can say that that is in a direct proportion. So there's your telephone call. If you charged R2.80 per minute, the longer you speak, the higher it's going to be. Dealing with speed, that's not necessarily constant. Yes, you can be driving a constant speed of, say, 80 kilometers per hour. But if you're traveling from one place to another, let's say we're going from Joburg to Cape Town, we're going to be changing our rate constantly. We're going to slow down, we're going to speed up. At the end of the journey, we can look at an average speed, but we cannot deal with it at the minute per minute kind of intervals and work out our speed exactly then. It's not a constant speed. We also deal with a unit rate. A unit rate is very useful when you compared rates in which you've got quantities. So, for example, I go shopping and I want to know which is cheaper. Say I've got 2 kilograms of sugar or 5 kilogram of sugar. Now, how am I going to compare that? I'm going to take it down to a unit rate, the cost per kilogram. Then it's easy for me to compare two values. So my 2 kilogram, how much would that cost per kilogram? And my 5 kilogram bag, how much would that cost per kilogram? And then I can see which one is the cheaper of the two. So that's really nice, deal with unit ratios. So here's an example, okay, of the cost of milk per litre. If I say that milk is R9.75 per litre, and I know what I'm dealing with and which is the better bar. Before I move on to which is the better bar, I want to just give you a little bit of background for your better bar. Normally, the better bar would be the cheaper. Normally, you would want, well, the best value for money, as you would say it. So which is cheaper, then that's the one I'm going to buy. But if you're dealing with a budget and you've only got a certain amount of money to spend per month, and let's look, for example, at flour. So if flour, it might be cheaper to buy the bigger bag. That's normally the case. The bigger the bag of flour, the cheaper it is per kilogram or per gram. But if you're dealing with a budget, you might not actually have the money in that month to purchase the bigger bag. So be careful when you're given a question like this to not just go with, oh, it's cheaper, therefore it must be better. So if I'm taking a budget of, let's say, 800 Rand per month to buy my groceries, and my bag of flour costs, say, I can get a 10 kilogram bag of flour for, say, 100 Rand. Do I want to use my full 100 Rand out of my budget to buy flour? It might be better off for me to buy a smaller bag of flour, even though it'll cost me more per gram, but I have the money for that. So it's just something to bear in mind that we need to consider when we're answering questions like that. Right, I think we've done all the definitions. Let's go through and answer some questions. So, question 1, we look at Vusi. He's opening a frozen yogurt kiosk at his local cinema. He has bought a chest freezer for the kiosk. The freezer is 150 centimeters wide, 80 centimeters deep, and 160 centimeters high. So, we're going to use the formula, and they give us the formula of our volume is equal to length times breadth times height to calculate the capacity of the freezer or the fridge in litres. And then we're told that 1,000 centimeters cubed is equal to 1 litre. So, let's go find some space and let's do this calculation. First of all, I'm going to draw my freezer. Right, I'm going to go back to look at these values. Right, it was 150 centimeters wide, 80 centimeters and 160. So 150, 160 and 80 centimeters. Those are my three values that I have. Not drawn to scale, I understand that, and it's not important as long as we got our values. So I've got my length, my breadth, and my height. So my volume is now, and always write in your formula because it'll help you later on. It's the same formula they've given me, but I know now it's harder for me to make mistakes. So my volume is the length, 150 centimeters, times 160 centimeters, times 80 centimeters. And let's do the calculation on the calculator. 150 times 160 times 80. And I end up with 192 and lots of zeros. How many zeros are there? 4 zeros. So let's go back and write that answer in. Right, 192, 0, and another 3 zeros, and the unit. Don't forget your unit. So what were we dealing with? We were dealing with centimeters, and its volume, it's three-dimensional, so it's centimeters cubed. So that's my answer. Did I answer the question? Let's go back and check. So calculate the capacity of the fridge, but I want the capacity in liters. And I know that 1,000 centimeters cubed is equal to 1 liter. There's my ratio. I've got 1, 2, and I've just calculated the third value, and I want my answer in liters. So let's go back here, and let's use my blocks. What do I know? I know that 1,000 centimeters cubed is equal to 1 liter. What have I calculated? I've got this 1920 and 3 zeros. Centimeters cubed is how many liters? Can you see I've stuck to the structure that I was discussing earlier? What I've been given is at the bottom. What I'm being asked is at the top. There's my centimeters cubed, and there's my liters. So everything is structured in the exact same way. And now I've basically solved the solution. I've got my solution. Because what do? Whatever's below my question mark, I cross out, I multiply on the other side. Multiply by 1, don't really need to do that. So I can say this is 1920, 3 zeros divided by 1,000. And what do I notice? I can just cross out my zeros, 3 zeros, and I get an answer of 1,920, and my answer is liters. That's how many liters the fridge can hold. Have I answered the question? Let's go back and check. Calculate the capacity of the fridge in liters. So I've answered my question and I've got my 3 marks. Now, let's go on to the next part. Vusi buys frozen yogurt in 25-liter containers. Calculate the approximate number of 25-liter containers that the fridge is able to hold. So, we know that our fridge can hold, what are we doing? Part 2. We know that our fridge can hold 1,920 liters. We have 25-liter containers. So I want to know how many 25-liter containers I can fit into the fridge. So what am I going to do? I'm going to take the size of the fridge or freezer and I'm going to divide it by how big is each container. Let's do that on the calculator. I get 1920 divided by 25 and I get an answer of 76.8. So let's write in my 76.8. 76.8 what? 76.8 containers. Now there's like a warning bell going off in my head. What is the problem? We cannot have 0.8 of a container because you can't buy 0.8 of a container. What does it mean? It doesn't mean anything. So with containers, we need a whole number. So do I make that 77 containers and round it up? I've got a problem with that. The problem is 77 containers are not going to fit into my fridge. That's too much. So in this case, we actually need to round down to 76 containers. Because only 76 containers will fit into the fridge. So go back, check the question. Have I answered the question? The question wants to know the approximate number of 25 litres container that the fridge is able to hold. Yes, I've now answered the question. Let's go on to the third part. The third part says, will he actually be able to fit this number of containers into the freezer? And explain your answer. Let's find another piece of paper. So we had, our answer was 76 containers. Whoops. That's what we had. We had our fridge was 1,920 litres that it could contain. Those are the facts that we have. Now, I've just done the calculation to show you that 76 containers will fit into the freezer. So why do they ask such a silly question? So let's think about it. What happens when you pack your freezer? Well, I don't know about you guys, but I am a terrible packer. So I'm going to leave lots of space at the bottom in my first layer, lots of space in the second, and I'm going to have a disaster. So part of this litres is going to be taken up by space. Now, if I've left space in the freezer, that means I can no longer fit 76 containers in. So maybe this question wasn't so silly. Let's go back and read the question again. The question said, will he actually be able to fit this number of containers into his freezer? And explain your answer. So I'm now going to answer this, and I'm going to say, actually, no. There really is no way that that will fit into. And not only that, we haven't taken into account the actual box that this container comes in, because that's also going to take up space. Even if it's a few millimeters here and millimeters there, just the box takes up space. So I'm going to go with no. And now I need to explain it. So the one reason I said to you was the packing of containers. Packing of containers takes up space. Oops. The packing of container. The actual box of container takes up space. The box of the container takes up space. And all these things leave us with less space in the fridge for the 76 containers. So, and when you answer a question like this, give your answer and don't forget to give your explanation, and make sure that your examiner understands your explanation. And kind of like think out the box. There are probably 10 more reasons that you can think of that I haven't thought of that would work in this situation of why it would not fit in. Right. Double check, have we answered the question correctly? So he said, will he actually be able to fit it in? We said no, and we did explain the answer. Right, let's move on to the next part of the question. The table below lists the various tub sizes that Vusi will be using for the frozen yogurt. So he's going to be using, let's look at our table. This is our tub size, and there's our tub size. Okay, so we've got tub size of small is basically 125 mils, medium 250 mils, and large 500 mils. So those are the sizes of tubs that he's going to be using in his kiosk. He does a little estimate that the various tub sizes will sell in the following ratios. Now they tell me I'm dealing with ratios, so I know that that's what I'm going to be dealing with. I've got 1/5 small, 3/10 medium, and 1/2 large. Now, as soon as I see those different fractions, they kind of confuse me. So I go back and do this slowly, one step at a time. So first, let's analyze that. Let's read the question and then we'll come back to analyze that. Right, so if Vusi has 1,500 litres of frozen yogurt, use the information given above to calculate how many of each tub size he will sell. Right, first I'm going to go to these fractions. I've got 1/5, I've got 3/10, and I've got 1/2. And that's kind of confusing me totally. So because they're fractions, we can deal with them in the same rate. These are ratios. So 1/5 to 3/10 to 1/2. I'm going to make these all equal and the same denominator. So I'm going to say, well, okay, let's make them all out of 10. Just because then it'll make it easier for me to deal with the ratios of each other. So 1/5 is equal to what over 10? Let's do this here. Right, 1/5 is equal to something over 10. What do I do here? Multiply by 2. So multiply by 2 there, and I end up with 2 out of 10. And right, 3 out of 10 was already like that. And 1/2, we're going to do the half as well. So 1/2 is equal to how much over 10? And in this case, what did I do? It's a 10. I multiplied by 5, so we multiply by 5, and I end up with 5 out of 10. Okay, that makes it a whole lot easier for me to do the next part of the calculation. So I now can see that my ratios, because I've got the same denominator, my ratio of small is actually 2 to 3 to 5. Those were my ratio of the small to medium to large. And now the question said, go back to the question, if he uses 1,500 litres of frozen yogurt, use the information to calculate how many of each tub size. This goes back to the question I was dealing with when we were dealing with the juice, and we needed 2 litres of juice. We've got our total, how much frozen yogurt he needs. So, and we've got our ratio. How are we going to deal with the 2? Well, we're going to take our 1,500 litres of frozen yogurt, and we're going to divide it by how many parts do we need? Well, our ratio was 2 to 3 to 5. So if I add those, I see that I need, and I don't think we need a calculator for that, I see that we need 10 parts. So what I'm going to say is I'm going to take my 1,500 litres and I'm going to divide it by 10. And I don't think I need a calculator for that either. So I've got 150 litres per part. But that hasn't answered the question, because the question said, how many of each tub size will he sell? So let's go back to our ratio. We know we need 150 litres per part. And now what I'm going to do is I'm going to multiply by my ratio, because I needed 2 parts of small. So my small I needed 150 times 2, which is 300 litres. And do the same thing for medium, 150 litres, and my medium was 3 parts medium, so times by 3, and in this case I get 450 litres. And lastly, 150 litres times by 5, that was for the large. And do we need a calculator? 150 times 5, and we get 750 litres. So I've now answered the question because I've told them how much of each we need. And I can write this back the way it was. Remember we had it as small to medium to large? Well, let's write it the same way. So I need 300 litres to 450 litres to 750 litres. And that answers my question. Double check. Wanted to know how many of each tub size he will sell. So we have answered the question. Right. Let's move on to the next example. To the next question. This question is broken down into a few different questions, so I'm going to do one question at a time and we'll move on to the next page. So, A says, find the value of P if 480 to 200 is 36 to P. Ratio. I'm dealing with my colon, and I've got 3 values that I've been given and the 4th value that is an unknown. So let's find some space. Right, let's do A. So I'm going to deal with this in my table. So going back, what was I given? I was given 480 to 200. Now in this case and in this example, we haven't been given any values. We don't know 480 watt or 200 watt, 36 watt, P is what, but it doesn't matter. We deal with it the same way. So my first value and my second value, that's what I'm going to call them. So I've got 480 to 200. That's what I've been given. Now what am I being asked? I'm being asked for my 36 to P. 36 was my first value, so I need to put that into 36 into the first column. And now I've got my given in one line, my question in the other, first value, second value. And that basically is my question mark or my P. What do? Whatever's below my question mark, I cross out and I multiply on the other side. So my answer to this would be 200 times by 36, and remember I said that was divide by 480. Let's use a calculator. We've got 200 times by my fraction, 36, divide by 480, and I get an answer of 15. So P is equal to 15. Is there any way that I can check this? I think there must be. So I'm going to go back to my calculator and see if I write in my first fraction that I was given, my first ratio that I was given, and let's say that is 480 to 200. I end up with 12 to 5. So that's my equivalent fraction, 12 to 5. Let me check my 36 to 15, and I see it is also 12 to 5, which means that I know that I've got this question correct. And it's really great in a test where you actually can check yourself and you know that you've got something right. So P is 15 was perfect. Right, let's go on to the next question and see what that's all about. There are 11 players in a soccer team. There are 49 boys in grade 11 at your school who play soccer. So don't worry that it's soccer and you might not know anything about soccer. They've given you all the facts that we need. We need to know that there are 11 players in a team. And we've got 49 boys in grade 11 at the school who play soccer. So what does the question actually ask? What is the maximum number of soccer teams that can be made up of these 49 boys? So let's find some paper. Move down here. Right, we're dealing with question B. So we know there are 49 players in grade 11 who play soccer, and we know that there are 11 per team. So to calculate how many teams, we're going to take a total number of boys and we're going to divide by 11 players per team. And let's do that on the calculator. So we've got 49 players and 11 per team, and we end up with an answer of 4,45. Let's round it off, so 4,5. So we have 4,5 teams. Now, does that make sense? Not to me, because we cannot have 0.5 of a team. We can't go and play 4.5 teams of soccer. So we need to round off. Now, if we round up to 5 teams, we don't have enough players. So in this case, we're going to round down. So the maximum number of teams that we can play is actually 4 teams. Go back and check the question. Have we answered the question? Says, what is the maximum number of soccer teams that can be made up? Yes, we have answered it. The maximum is 4. Then the next part of the question says the ratio of soccer players to non-soccer players in grade 11 is 1 to 3. They told me here that it's a ratio. So I know I'm going to need those blocks. What have I been given? I've been given the ratio of 1 to 3. And I want to know what the total number of learners in grade 11 is. So let's go through the ratio and let's see if we can get the answer. So, first we're going to say in our blocks. Right, this was the second part. We've got our blocks. What do we know? We know that the ratio of players to non-players is 1:3. How many soccer players did we have in grade 11? We had 49 soccer players, which means that this is my unknown. Remember, I've set it up correctly. I've got my given at the bottom, my question at the top. That's my soccer players, and that's my non-soccer players. So first let's calculate this and see if we've answered the question. Whatever is below my question mark, I cross out and I multiply on the other side. So I'm going to say that is 49 over 1 times by 3, or 3 times by 49 over 1. My 49 over 1 doesn't mean anything, my over 1. So on my calculator, I can simply say 49 times 3. And I see that it's 147 non-soccer players. So let's write that number in. So I have 147 non-soccer players. And always fill in all your values, all your calculations. We need to know exactly what steps you're doing. Don't just write in an answer. You are liable to lose all the marks if you get it wrong. Whereas if you get it wrong, but you've shown all your calculations, you will end up with method marks. So please don't forget those crucial method marks. Now I want to go back to the question. Have I actually answered the question? The question says, what is the total number of learners in grade 11? That means total, meaning soccer players and non-soccer players. So how am I going to get my total? I'm going to say, well, okay, my total is my soccer players and my non-soccer players. So how many soccer players were there? There were 49 soccer players, and I worked out there were 147 non-soccer players. So let's add those up and get a total. So I've got 147, I've already got that on my calculator. I can just add my 49 and I get 196 learners. So go back to this, it's 196 learners. So before we carry on, I just want to go back to this step and double check that my ratio was correct. So it was my 49 and 147. I'm going to just take my 49 and divide by 147 as my ratio and see I've got my 1:3. So I know that my answer was correct. I've answered the question fully, so I've got no mistakes here, which is perfect. So always remember to double check. Always remember to double check, have you actually answered the question? So get into the habit of just going back to checking. So we know we've answered that. Let's go on to C. Now, our soccer team practices for 4 hours a week. The coach increases their practice time by 8%. For how much longer will they practice now? So let's do it at the bottom of this page. They're practicing at the moment for 4 hours. He's increased it by 8%, but remember, whenever we deal with percentage, we need to multiply. So we're going to take our 4 hours and we're going to times it by 8%. And let's see what answer we get there. So 4 hours, leave out our hours, times by 8%. And we get an answer of 0,32. So need to discuss that with you for a second. We've got 0,32 hours. Now, first, have I gone and answered the question? The question says, for how much longer will they practice now? And we can leave the answer as 0,32 hours. But be careful if you change that into minutes. Please be aware, hours is out of 60 minutes. So we cannot say this is not equal to 32 minutes. And I know that's something that you are inclined to say, and you usually give us that answer. And it's a very frustrating answer. It is not 32 minutes. So if we want to change this into minutes, what are we going to do? Well, we're going to say, we can do this two ways, and I'll show you both. We can either say, well, 0.32 hours times by 60 minutes. So let's do that on the calculator, and we've got our 0.32 there, so times by 60, and we get an answer of 19.2 minutes. So we can write that in as 19.2 minutes. And be careful, it's not 19 minutes and 2 seconds or 20 seconds. So we can actually get this to a more exact number if we now want to take our 0.2. Let's try that. Let's get a little bit more space there. And now let's take our 0.2, 0.2 times by 60 to work out it's 12 seconds. So we can actually say, well, okay, that is 19 minutes and 12 seconds. That's an exact answer. You didn't need to do any of these calculations because the question, go back to the question, just said, for how much longer will they practice now? Just showing this to you because it's just a quick thing that we can do now. And I said there was another way to actually calculate it. So I'm going to put an or. On your calculator, we have this little button, which gives us these little squares. It's the time button. How do we use it? We actually use this as hours, minutes, and seconds. So, what do we know? Our answer was 0.32 hours. So, I'm going to type that in as 0.32 hours and 0 minutes. That's my answer. When I press equal, I actually am given my answer in 0 hours, 19 minutes, and 12 seconds. So it's a quick shortcut for you to use if you want to deal with time. So all here was use your calculator. With a calculator, and we get the same answer of that 19 minutes and 12 seconds. Right, have we answered the question? We have. Let's move on to the next question. Right, question D. It takes approximately 5 minutes for water heater to boil 2.5 liters of water. How long would it take the same heater to boil 50 liters of water? Give your answer in hours and minutes. So, how long is my question? What have I got here? 1, 2, 3 pieces of information, and I'm asked the fourth. So lo and behold, this is a ratio. So how am I going to solve it? I'm going to use my blocks. So let's set up the blocks. This was question D. Question D, I'm going to set up my blocks. Right, what have I been given? I've been given that it takes 5 minutes for 2.5 liters of water. That's my given. So I'm going to fill that into my blocks. It takes 5 minutes for 2.5 liters. That was given, fill it in at the bottom. What am I being asked? I'm being asked how long, so I'm looking for time, and to boil 50 liters of water. So I know I've got a question mark and I've got 50 liters. Where's my 50 going to go? My liters are in this column. So I'm going to make that 50 liters, and there's my question mark, and it gives in time, so it's how long. Right, whatever's below my question mark, I cross out. Multiply on the other side. So what does this actually mean? It means I've got 50 over 2.5 times by 5. And let's plug that into our calculator. So use the fraction button, 50 divided by 2.5 times by 5, and I get 100. So let's write that in. I've got 100. 100 what? 100 minutes. Have I answered the question? Let's go back to the question and see. The question said, how long would it take? I've answered that part of the question. But the question then says, give your answer in hours and minutes. So I'm missing that crucial fact. I've got 100 minutes, but I need to know how many hours that is and how many minutes. So let's go back to the answer. If I've got 100 minutes, I'm going to divide by 60 to get it into hours. So 100 divided by 60 is basically giving me 1,666 recurring. So I've got 1,6 hours. How am I going to convert that 0.6 into minutes? I can take it and times by, I can do this two ways. I can take that and times by 60. So let's try that first. I'm going to just delete the 1. So I've got my fraction. There's my decimals, and times that by 60, and you'll see that it's 40 minutes. So it's 1 hour and 40 minutes. The other thing I could have done is, once I'd calculated to 1,6 hours, is take my 100 minutes minus 1 hour, which is 60 minutes, there's my 1, and I end up with 40 minutes remaining. So from that I can clearly see that it is 1 hour and 40 minutes. Right, have we answered the question? Go back to the question, and we've answered it in hours and minutes. Let's move on to the next one. Sasha has a part-time job, and she saves 9.2% of her monthly salary. If she saves 115 Rand each month, what is her salary? This is a percentage calculation, and it's also a ratio. So let's deal with it as a percentage. So she saves 9.2% of her salary, and she saves 115 Rand each month. So we can write this. Let's get some space. Right, we had her salary. And she saves 9.2% of her salary, and we get an answer that is 115 Rand. So if we write it like this, this is the statement. I'm going to go back to the statement and see that we've got it correct. This is the statement that we have here. She saves 9.2% of her salary, and she saves 115 Rand. And the question is, what is her salary? So we've written that out correctly. And now all we need to do is solve it and find her salary. So I'm going to try to get the salary on its own. I'm going to eliminate everything else that is around it. So I'm going to divide here by 9.2%, because then those cancel, and I'm left with the salary on its own. But what I do to the one side, I have to do to the other. So we end up with her salary, let's just rewrite that, is equal to 115 Rand divided by 9.2%. And now we can calculate that on our calculator. So we can use the fraction button, 115 Rand divided by 9.2%, and her salary is 1,250. 1,250. I can double check that. I can multiply that by 9.2 just to check that I have got the correct answer. So let's quickly check that. Let's do that. So if I take my salary that I've calculated times by 9.2, that's not a 9, 9.2%, that's not a percent, and I get 115 Rand. So I know my answer is correct. Okay, let's see, have we answered the question correctly? The question said, determine her salary. We've calculated her salary, so we've got that correct. Right, moving on to question F. Right, let's space there. Right, 4,800, let's try a different color for a change. 4,800 Rand is shared in the ratio of 7 to 3. Determine the difference between the larger and the smaller share. Well, before I can determine the difference, I need to determine what the shares are. Now, I've been given a ratio of 7 to 3. So I've got to take this and split it up into that ratio. So what's the first part that I need to do? Is I need to find my part per share. So we had 4,800 Rand, and we needed to split that in the ratio of 7 to 3. So how many parts did I need to split this? I needed to say that was 7 plus 3. There were 10 parts. So I'm going to take my 4,800 Rand and I'm going to divide it by 10 parts. And what do I see? I see that I've got 480 Rand per part. Where did we go? Per part. 480 Rand per part. But that doesn't tell me the ratio that they were split in. Remember, they were split in the ratio of 7 to 3. So I'm now going to multiply each of these by 480 Rand because that's per part. So 480 times by 7, and I'm going to say 480 times by 3. Now let's do those two calculations. So 480 per part times by 7 parts is 3,360. And remember, there's a reference to this. Your units are rands. And now we're going to do the same thing with 480 times by 3, and we get 1,440. And that's how this money is split. I can check that. Let's double check that before we carry on. So if I say 3,360 divided by 1,440, use my ratio as my fraction, I should get 7 to 3. So I know I'm correct. But let's go back. Have we actually answered the question? The question said, determine the difference between the larger and smaller share. What does the difference mean? The difference means you need to minus the one from the other. So we haven't answered the question fully. Let's go back to our calculations. We've got those two values, but we want the difference. So we're going to take our 3,360 minus 1,440. That's going to give me the difference. So do that on the calculator. 3,360 minus 1,440, and I get my answer of 1,920. That is the difference. So I've now answered the question fully. Please don't forget, get into the habit, go check the question again. Have you actually answered what they're asking? You know, sometimes we get so involved in us answering the question and we know exactly what we're doing and we quickly want to get it done that we forget to double check and we miss those little marks that are so crucial. Right, let's do number G. We've got some space over here. We'll do it here. It costs 1,560 Rand for 7 people to attend a King of Leon concert. 5 more people joined the group, now totaling it to 12. Where did our 12 come from? 7 people plus another 5. And we want to calculate the new total price. What have I got? I've got 3 values and I'm being asked a 4th, a ratio. So we can use our blocks to calculate this ratio. What have we been given? We've been given the cost of 1,560 for 7 people. What are we being asked? We're being asked for the new price, so that's my cost, for 12 people. Once I've set this up, I've got people on the one side, my money on the other side, what's been given, and what are being asked. Once I've set it up, easy for me to calculate. Whatever is below my question mark, I cross out and multiply on the other side. I want you to still show your calculations for this. So let's write it in. It'll be 12 over 7 times by 1,560. And we can do that on our calculator. This is the fraction button. 12 divided by 7 times by 1560, and we get an answer of 2,674 and 29 cents. We're going to round up, so 2674 2674 and 29 cents. Double check that I've got that correctly. 2674 and 29 cents. Don't forget, money is always 2 decimal places. Money is always 2 decimal places, so don't leave them off. Those 29 cents are very important. All right, so that takes us to the end of the exercises that I'm going to be dealing with you. Now, just to give you a couple of hints on what the exercise you're going to be doing at home. First of all, I want you to read the question carefully. Do your calculations and remember to go back and check, have you actually answered the question? Let's do a quick recap of what our ratios look like. So, use the tables. Use the tables that I've explained. You've got to put your given at the bottom. That's what they've given you. And then 1 unit that side and the second unit in that column. And then your question basically at the top. And then remember, whatever's below your question mark is what you cross out and multiply on the other side. This is going to make your homework exercise a whole lot easier. I also want you to not be scared of formula. In your exercise, they've given you a formula for the temperature converting between degrees Celsius and degrees Fahrenheit. Just deal with it one step at a time. I know that you can do it. I've got a lot of faith in you, and just take it easy, one step at a time, and make sure you've answered the question. And I think that pretty much takes me to the end of this session. I hope that I've helped you understand rate and ratio, and good luck with the homework exercise.